All right, this is the second part of section 4.2. We're going to talk about the quotient rule. So let's say, for example, I have 5 to the 8th divided by 5 to the 4th. So if I write 8 fives, let's see, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. All right. And then 5 to the 4th. 2, 3, 4. Okay. So if I have 8 fives divided by 4 fives, what I can do is I can kind of divide them one at a time. So if well, two at a time, I guess. If I take 5 and divide it by 5, that gives me 1. So right here, I have times 1. And here also, I have another times 1, and another times 1, and another times 1. So I have 1 times 1 times 1 times 1 times 5 times 5 times 5 times 5. So times 1, it doesn't matter. We don't care about times 1. What we do care about is the 4 fives that we are being multiplied together. So what happened? I started with 8. I divided 8 fives, and I divided by 4 fives, and it ended up with 4 altogether. So I basically canceled out pairs of 5s to get my 4 remaining. If you wanted to do a shortcut, which I don't recommend actually, I recommend thinking about it this way, even if you don't write it out, we actually subtracted the exponents. All right, so here we go. So again, what I want you to do is either write it out, which is what I recommend, or you can mentally think about writing it out. 2, 3, 4, 5, 6, 7. And what I want you to do is 2, 3, 4, is ask yourself how many pairs of 4s will cancel out to make a 1. All right, so we have 5 pairs of 4s that we canceled, and we end up with 2 4s in the numerator. 4 squared, or 16. Okay. Again, we're going to have 5 pairs of 4s that will cancel out. 5 on top and 5 on the bottom. And we're left with 2 4s on the bottom. And so we have 1 over 16. You can't do it with negative exponents. You have to do it with positive exponents. So you are first going to rewrite it with positive exponents. Then you're going to cancel out your pairs of x's. So I can do 6 total, and that will leave me with 6 in the top. Okay. All right. Deal with a negative exponent first. One step, one rule. We're doing the negative exponent rule. We're going to take this n to the negative 3 and put it in the denominator. Okay, we only did one thing. That's it. One step, one rule. Now we're going to use the quotient rule. Okay, we're going to ask ourselves, how many pairs of 8s can we cancel? Well, I can cancel 4 of them, and I have 1 left in the bottom. I can cancel 9 m's, and I'm left with 1 m in the bottom. I can't do this rule yet because one step, one rule. Nothing left in top, we're going to put a 1. So we did the quotient rule here. Okay, so we did the quotient rule. Now we're going to use the product rule. We're going to multiply these, and we have 2 n's and 3 more n's, so altogether we have 5 n's being multiplied. Ask yourself, did you simplify the coefficient? Yes, we did. Did we write our answer with all positive exponents? Yes, we did. Did we write our variable more than once? No, we didn't. We're good to go. All of the rules that we have talked about, these are all of the exponent rules. We are going to put all of these rules to work, usually all in the same problem. So kind of the order you should probably think about doing this is power rule, then negative exponent rule, then quotient rule, and then product rule. Good rule of thumb. Okay, one more time. Start with the power rule, then the negative exponent rule, then the quotient rule, and then the product rule. In general, that's a good idea to do exponents in that order if you have multiple. And I didn't realize I had this. Write this down. Write it down. It's important. Okay. So it's not critical that you do it in this order. And notice I actually did switch these. But it's just a really good rule of thumb. Okay. All right. So we've got an exponent outside. One rule, one step. So we're just doing the power rule right here. So 3 to the 4th. I'm going to clear this. Hold on. Multiply the exponents. 3 to the 8th. Okay. Now we're going to use the quotient rule. We can cancel out 3 pairs of 3's. We're left with 5 pairs of 3's in the top. Power rule. So 4x squared, 4 squared, x squared. Let me just rearrange it. Okay, now we're going to use the product rule. So we've got 4 3's being multiplied, and we've got, sorry, 3 4's being multiplied. I said that the wrong way. And we've got 4 x's being multiplied, and 64 x to the 4th. All right, we've got this power, but it is negative. So let's make it positive first. So we're going to take the reciprocal of this fraction right here. So 6, 5y squared to the positive 2. We're going to use the power rule. So 6 squared, 5 squared, y squared, squared, which is, I probably could have simplified the 6 and the 5, sorry. 25y to the 4th. Okay. All right. This one, there's a couple different ways we can start this one. And I am going to need a lot of room. So what I'm going to do is I'm going to, even though this is a negative exponent, what I'm going to do is I am going to apply the exponent to each of the items inside. And the reason I do that first, as opposed to how I did it here, is because this is a whole fraction with a negative exponent, where this is just, that's not a fraction. It's not a fraction inside here. So again, like I said, there's different ways you can do this, but this is the way I'm going to do it. So all I'm doing right now is just applying this exponent to each of the ones inside. Nothing else. One step, one rule. Okay, so now I'm going to use the power rule here. So 3 to the 9th, x to the negative 4, multiplied my exponents there. 3, y, that should be an x to the negative 4, and y squared. Okay, so I've got my power rule done. Now I'm going to do my negative exponents. Okay, so negative exponent is going to go to the bottom. Negative exponent going to go to the top. Negative, come to the bottom. So I'm going to rewrite it. 3 to the 9th. Notice I'm not doing anything else other than just these negative exponents. So the bottom one comes up to the top, and the top one comes down to the bottom, and my y comes down to the bottom, and my y, this y still stays in the bottom. Okay? Quotient rule. Okay? I'm not going to worry about the product rule yet. I'm just going to do the quotient rule. So now I am going to, the quotient rule. How many pairs of 3s can I cancel out? Well, at most I can do 3 3s. So I've got 6 3s left on the top. I can cancel out all 4 of my x's. And let's go ahead. To be honest, I don't know what 3 to the 6th power is. Let's see. 3 to the 6th power, 729. All right. This one is actually a lot. There's a difficult way to do this one. There's an easier way to do this one. Notice this is 8R. This is also 8R. This is 8R, and this is also 8R. So what I'm going to do is just leave this together as 8R. Okay, I'm going to do this. So I'm going to leave this 8R to the 4th, and I'm going to bring this down. I'm going to bring this up. So 8R to the 8th, 8R to the 3rd, 8R to the 10th. Okay. And now I'm going to use the product rule. So I'm going to add these exponents because the base is the same. Base is the same, so I can add the exponents. And then now I'm going to use the quotient rule. I've got 12 8Rs in the top, and I've got 13 8Rs in the bottom. So I can cancel out 12 of them, and I'm just left with 1 8R in the denominator. Is this the only way to do this problem? No. I could have done the power rule, negative exponents. It's a whole lot more writing. This is actually easier. And that is the last slide. So